This is Honors Geometry Lesson 7.1 Part 2. We're going to try some more Pythagorean theorem problems. The first one we have is a square, and we know the length of the diagonal is 10 centimeters. The question is, what are the lengths of the sides? So we're going to use good old Pythagorean theorem. We're just going to say that x squared plus x squared, that's my a squared plus my b squared equals my c squared, which is the hypotenuse, which is 10 squared. We all know that 1x squared plus 1x squared gives us 2x squared, gives us 100. Divide each side by 2, and looks like x squared equals 50. Let's go ahead and square root both sides, and let's give our answer as a radical. So we're going to say 2 times 25, 5 times 5. Looks like our pair of 5s comes outside, and our 2 stays inside. So we know the length of the sides are 5 root 2. Second problem, we have an isosceles triangle, and we're looking for the height of that triangle. In an isosceles triangle, this is called the altitude or the height. It splits the third side proportionally. It splits the third side in half. So I can assume that this is 24 and this is 24. So we simply have to do the Pythagorean theorem. Make some room to work here. So we have 24 squared plus h squared equals 44 squared. 24 squared is 576 plus h squared equals 44 squared is 1936. Subtract 576 from that. Looks like we get 1360. Square root both sides. And I'm going to go ahead and break that down into 10 times 136, 2 times 5. That's even, so I'm going to go ahead with 2. That's 68. 2 again, 34. 2 again, 17. All right, let's find our pairs. Looks like we have a pair of 2s. Looks like we have another pair of 2s. And it looks like we have a 5 left over and a 17 left over of our prime numbers. So it looks like we're going to have 4 root 17 times 5, 85 will be the height of our triangle. All right, this one, let's go ahead and find the height or the length of that segment. So I'm just going to chop this trapezoid from a trapezoid into a rectangle with a triangle. So I'm going to carry over the 14. I'm going to take 20 minus 11. That's going to give us a length of 9. And we're back to our right triangle. We're looking for the hypotenuse. So we have 9 squared plus 14 squared equals x squared. 277. 277 equals x squared, and we're going to square root both sides. All right, I'm going to move on just to save a little bit of time. Last one, we have a rectangular prism, and we're looking for the length of the diagonal from one corner to the other. So the first thing I'm going to do is find the length of the diagonal of the base. So I'm going to carry this 9.6 to the other side. I'm going to draw in the diagonal. So now we're looking at this right triangle. And we can easily do that with Pythagorean theorem. So we're going to say 9.6 squared plus 2.8 squared. This one has decimals, so we're going to give it a decimal answer. Equals x squared. 9.6 squared plus 2.8 squared gives me 100. Oops, looks like we're not going to need a decimal. Equals x squared. So it looks like our diagonal is going to be 10. Now we're going to look for this other right triangle. So I'm going to carry the 7.5 over here. I know this is 9.6. That was given. Oops, I'm sorry. That's not the one I want to use. We now know that this is 10. Let's try that again. So we have 7.5. We now know this is 10. And now we're looking for the hypotenuse of this right triangle. Piece of cake. So we're going to do Pythagorean theorem again. 7.5 squared plus 10 squared equals our hypotenuse squared, which is the diagonal of our rectangular prism. 7.5 squared plus 10 squared gives me 156.25 equals c squared. And again, because we're dealing with decimals, we're just going to leave it as a decimal. We want the square root of 156.25. And it looks like the length of our diagonal is 12.5 centimeters. And that seems like a reasonable answer. Please try the 7.1 practice 2 and let me know if you have any questions. Thank you.